So I'm really excited to share with you containerized deployments for your SPA and API. A lot of times when we look at containerizing our applications, we just get one container into place and then we go, ta-da, we're done. We're going to dig a lot deeper today. Here's the part where I tell you, I am definitely going to post the slides on my site tonight. I've been that person chasing the speaker, and it hasn't worked out very well for me either, which is why the slides are online right now. I put the slides link in chat in addition to the link to the code that we'll see today. And all of that is really easily available from robrich.org. So let's head to robrich.org. We'll click on presentations, and here's create robust deployments for your SPA and API. The slides and the code are online right now. Achievement unlocked. While we're here at robrich.org, let's click on About Me and see some of the things that I've done recently. I'm a Jetpack developer advocate. Microsoft has given me some awards. I'm a Docker captain and a friend of Redgate. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp closer to you, find me here at the conference or find me on Twitter or email, and let's get a Give Camp in your neighborhood too. Some of the other things that I've done, I replied to a .NET Rocks podcast episode. They read my comment on the air and they sent me a mug. Woohoo! So I've done a lot of .NET things, but today our focus is Java here in a Java conference. So in the code that we'll see, we have a .NET version, a Java version, and also a Node version. And so digging into the Java version, we'll see all of the examples that we're going to look at today. And you can dig in, clone the repository, and replicate these results. So let's dig in. When I'm deploying my SPA, my single page application, or my progressive web app, my PWA, how do I deploy that? And how do I deploy the backend? Should it be one container or two? One domain or two? A single page application. We move towards single page applications because they're very interactive. We don't need the page refresh. We can cache the data locally. We can work offline. It can run anywhere without an install, which is really amazing. You know, everything running inside the browser works really well. We don't have a difficult deployment story. The backend is really helpful because we can consume it not only from our website, but we could consume it from other devices, maybe mobile devices or phones or tablets or watches or other non-traditional mechanisms. Now the API is probably a REST API. It might be GraphQL or a gRPC, but because that data is now available, we can consume it in a really elegant way. Our API can focus on making data available, and our SPA, our website, can focus on making it interactive. And that separation is really elegant. But separating the UI and the API does yield some additional complexity. There is some operational efficiency if we have those things separate. We don't need to focus on multiple concerns at the same time. But now we need integration points. We need to be able to talk to each other. And that makes it more complex. So is that complexity worth it? We'll see. So how do we deploy those pieces? Now, traditionally, what we'll use is we'll deploy into Docker containers, and we'll deploy those onto Kubernetes. Now, we could definitely take our SPA, our static assets, and deploy them into just a static site thing, maybe blob storage or S3, and run the site statically there. But for today's experiment, let's use containers for all the things. So a Docker 101 talk might kind of look like this. And we're not going to focus too deep on Docker 101, but we'll kind of level set here to understand what is Docker. Docker is an ecosystem around container virtualization. Well, what do we mean by container virtualization? We're virtualizing the kernel, the operating system, instead of the hardware like we do with traditional virtualization. So Docker is this suite of command line tools that makes that virtualization process easy. Now, unlike traditional virtualization, unlike containers of the past or namespaces or jails, Docker makes it really easy for us mortals to be able to create these containerized applications. It's this suite of tools for creating, running, and managing containers. So we're probably, as an industry, almost past this slide, but just in case, here on the left, we have traditional virtualization, and on the right, we have containers. On the left, we see that with each copy, we need another copy of the operating system because we're virtualizing the hardware. On the right, we don't need that. We just need our application, the difference between the host operating system and what we need to run. So this is definitely not to scale, but we can see that previously we only had 3 applications. Now we have 7 running. We're able to use our hardware much more efficiently. Now, the container is virtualizing the operating system, the kernel, so we must match our host operating system with our guest operating system. So Linux containers need to run on a Linux host, and Windows containers need to run on a Windows Server host. Well, what's missing? Well, what about GNOME and KDE? What about Red Hat and Ubuntu? Can I run a Red Hat container on an Ubuntu host? Yes, we're virtualizing the Linux kernel, and the Linux kernel underneath Ubuntu is the same Linux kernel underneath Red Hat. So we don't need to worry about differences in brands of Linux. We can run them just fine. Another thing that's missing is Windows Desktop and Mac. If we go to docker.com and we say download, we get a Mac download, even for an M1 or an M2 Mac. How's this working? Well, in production, we definitely want to do it here on the right. We want to run as efficiently as possible, as close to the metal as possible. But in development on the left, we can do this. So I have my machine. Maybe this is my Mac laptop or my Windows laptop. I'll install my host OS. I'll install my hypervisor. In the case of Windows, this is Hyper-V. In the case of Mac, it's HyperKit. And then I can install a guest OS. Now, this guest OS is Linux, and it's just a regular virtual machine. And then I'll install the Docker hypervisor inside that Linux virtual machine so that I can run my Linux containers here. Now, that does mean that I have 2 hypervisors, but it allows me to then virtualize this Linux virtual machine OS so that I can run my Linux containers. Now, the cool part in Windows is this can be WSL2. So we've got Docker. And what makes Docker really elegant is that ecosystem, that system of building and deploying containers really easily. So let's double click into that. Now we start out with a Docker file, configuration as code, that lists the steps that we need to be able to build up our image. We'll take that Docker file and we'll build it into an image, a binary blob that has everything already configured and ready to go. We could choose to share those images with people on Docker Hub, or we could pull down images pre-built from Docker Hub or another registry. We can then start that image as a container inside of a Docker hypervisor. So I'll have my configuration as code, I'll build that into an image, and I'll run it as a container. We could think of this like a class file and an instance of our object. Or rather, this is our class file, this is our compiled jar, and this is our instance running inside of Tomcat. Now, what's interesting here is that what we're sharing with others is a binary blob, an image. We can attach the Docker file as metadata to it, but we're not sharing our source code with others in Docker Hub. We're actually sharing the compiled binary, which means if I download an image from Docker Hub, I don't need to recompile it. I already have that built content. Now, we can do this in a similar way with one image that we can with many images. Perhaps we're using Docker Compose or Kubernetes YAML files. We can specify many images, either via many Docker files or many images up on Docker Hub, and then start them together as a collection inside of a Docker hypervisor, perhaps Kubernetes. And this is the magic of Docker, this mechanism of having these really small configuration as code files that specifies the suite of tools that we need to be able to run in a virtualized environment. Now, ultimately, let's source control these configuration as code, these Docker files, but we'll get to build one today so that we can see how that works. Now, as we start to build this up into the SPA and API mechanism, we'll start to leverage a bunch of mechanisms for being able to run one container or two. But in development, we really take advantage of the Webpack dev server built into our SPA framework. Now, whether we're using React or Vue or Svelte or Angular, it's probably baked into Webpack dev server, maybe it's Vite. And we can say, hey, if you hit this /API route, I would like you to route over to this other thing. So the proxy is built, the reverse proxy is built into the SPA backend or the SPA dev server. And so in development, that's the mechanism that we'll use in all of these examples. So no matter how you're deploying your production system, Webpack dev server makes it really easy to deploy or to experience these in development. So let's scaffold and Dockerize an application. Now we want to Dockerize a Java application. So I come here to the Spring Boot initializer, start.spring.io. I chose to add some dependencies. Let's add Spring Web. And then we can choose the other details that we need. Do we prefer Maven or Gradle? What language would we like? I'll just leave it with Java. And I'll also select Java 17. So once I've chosen to generate that, I've downloaded that here. And we can see here in the 0 CLIs, we have that Spring Boot application. Now, I have modified it just a smidge to create a weather forecast controller. So here's my Spring Boot application, and it'll just launch my web app. And then I have my Pojo, my object that will just store some weather forecast details. And then here in my weather forecast controller, I just rig up to this API, /API/weather forecast, and I do some randomization just to generate some random weather data. Now, ultimately, I just want my API to be able to spit out something, so this will be perfect. Now, I want to package this into a Docker container. So the first thing I'm going to do here is I'm going to create a new file, and I'm going to call this .gitignore. Now, this gitignore file is everything that we don't want to commit to source control. So we'll have a few groups of things. We don't want to commit downloaded files. We don't want to commit built files. These things would just pollute our source control system, and they change so frequently. We also don't want to commit user-specific files, and we don't want to commit secrets. Now these are the and we also don't want to commit temp files. These are the 5 groups of files that we don't want in our source control system. Now, in the case of a Spring Boot application, for the most part, all of these end up in the target folder. So let's just ignore the target folder. Now, we could definitely ignore other things, star.tmp. Maybe we want to ignore the .vscode folder, the .idea folder, and other things like that. We can definitely enumerate all of the user-specific places where we might include files. But for the most part, we can just say, let's ignore the target folder. And that will get both downloaded and built files. But let's add .idea here, temp files, star.log, star.orig will come up inside of Git sometimes. So that's all the things that we don't want to commit to source control. Now we're here to containerize our application. We just spent this time building up a gitignore source control thing. How do we containerize it? Our first stop for containerizing it is to create a new file called .dockerignore. Now the dockerignore file is everything that we don't want to end up in our production container. And what's really amazing, it has the exact same format as our gitignore file. So let's go grab our gitignore file and set it into our dockerignore file. In fact, if we don't have a dockerignore file, but we do have a gitignore file, then Docker will use that .gitignore file as its dockerignore file. There's one more category, non-production content. Now, we don't want dev settings. We don't want .env to end up in our production container because those are local settings. we want environment variables to be able to set the settings inside of our Docker image. So now we have our Docker file. These are all the things that will never end up in our image ever. Even if we specifically copy one of these files, they won't end up in our image. Now that's good to know because, well, I spent a really long time trying to very specifically copy a file that was listed here in my Docker ignore, and it just wouldn't go. So hopefully I'll save you that few minutes. Next, we need a Docker file. So Docker file. Now it's important that this be named Docker file and not dockerfile.txt. So if your IDE automatically added the txt, easy to rename and pull that txt off, and now it's just Docker file. Now I happen to have the Docker extension installed in VS Code, so I have the nice whale icon. Your IDE may or may not show that as well. Here in the Docker file is the configuration as code that gets us from our source code to a running container inside of Docker or Kubernetes. Now there's 4 main verbs that we'll find: from, copy, run, and cmd. Now there's other commands in a Docker file, and we'll see some of them today. But with these 4 commands, you can probably read and write most Docker files almost completely. Now let's take a look at these 4 commands. We start out with from. We want to build on the shoulders of giants. So we want to start with a base image that has the things that we need in it. In this case, we'd like to build a Java Spring Boot app. So let's head over to Docker Hub and let's take a look through things. We'll search for OpenJDK, and we'll land on this page that includes the OpenJDK. We can take a look at the overview, and I'll very carefully not see the deprecation notice. If you have an alternate base image, definitely put it in chat. I would love to learn about the different Java base images. But what I like here is that if I search for 17, that's the Java version that we got. We have 17.0.2, but we also have 17. We have one with a JDK installed. There is also a an Alpine version of this. And so let's start with that as our base image. We will say from OpenJDK, and we'll use 17-JDK/Alpine. There we go. That's the image that includes the Java development environment and all of the build tools that we need to be able to accomplish this task. Next, let's copy everything. We're going to copy everything, except for everything we specified in this Docker ignore file, from the directory where we run our Docker build command to our current directory in the image. Now, where is that current directory? Let's set it, workdir/src. Now, we could definitely say var lib foo bar, wherever we needed it to be. It would not only create that directory, but cd into it as well. I don't need all that complexity, so I'll just say src. Now we have all of our source code here inside this container, and we can start to build our content. So let's run maven w package. Now we could definitely do clean package if that makes you feel better, but I'll just say package for now. Now that's going to go do a whole bunch of stuff and create this end jar file. So let's say java -jar demo -0.0.1.jar, and that happens to be in the src/target directory. Excellent. So we've just built up a Docker file that allows us to be able to run this application. We could definitely use this Docker file in production exactly as it is, but there's some things that we can tidy up here. There's some best practices that we haven't followed yet. One of the best practices is to not include a compiler or your source code in the final build image. It just makes it bigger. Right now, we have all the source code that we copied in, and we have the JDK here as well. So if we come back to Docker Hub, now there's one that includes the JDK and one that doesn't. I'm going to assume that this one doesn't include the JDK. Of course, I'm wrong. But let's do this. Let's say from OpenJDK 17 JRE Alpine. I wish that was a thing. It actually isn't. So let's comment this out, and we'll do what actually exists. This one without the JDK there. Now we don't have our source code in it. Unfortunately, this one still does have the JDK in it. So if there's a better base image to use instead of OpenJDK, definitely let me know in chat. I would love to learn about a better base image. Okay, so now we've got this separate image. We can say this one is our production runtime server, and I put that in air quotes because it's not a server, it's an image. But this from here down is our production image. And then this one is our build server image. So this includes our build tools. This one does not. That's excellent. We've created a multi-stage build. So now instead of this, let's say app, and we do need to copy our content. We need to copy /src/target demo 001 jar into the current directory. But now it's going to go look for something out here. We don't want it to be out here. We want to copy from equals build. Well, where's build? Let's name this one as build. Now we could definitely name this one as prod, but we're not going to use it that way. So there we go. Now we've removed our build tools and our source code from this production image and made it significantly smaller. That's excellent. We don't need all the Maven downloads. We don't need all of our source code. All we have is just a single jar file in our production image. Now there's one more thing that we can do to tighten this up. Each of these commands will create a Docker layer that is cached by Docker as it builds it. So if we're building locally and we want to just, I don't know, change some Java source code here, we don't necessarily want to re-download all of our dependencies, all of our Maven packages. So really what we want to do is run Maven dependency go offline. And this command will actually go download all of the packages and cache them. And then when we run Maven package, then we don't need to re-download those dependencies. So let's download those. We'll then copy in all of our source code, and then we'll run Maven package. Now we do still need our manifest to know which packages to download. So let's copy in pom.xml into the current directory. And we'll actually need a few more. We'll need pom.xml. We'll also need maven-w. Let's copy maven-w.cmd just for maven-w just for giggles. And let's put those in quotes since we now have a lot of them. And there we go. We also need the Maven wrapper. I tried to put the Maven wrapper directory here, and I didn't get that. I just got one file. So let's actually do that on a separate line. Copy.maven to .maven inside the current directory. And so now it will copy in our manifest. It will go grab all of our Maven dependencies. Then it will copy in the rest of our source code, and then it will package our asset. So if I just change a Java file, I don't need to re-download my Maven assets. Excellent. That'll make the build a lot faster. ADO OpenJDK, the other good JDK on Docker Hub. Excellent. Thank you, Virel. So we've got a Docker file now, and this is a great Docker file that we can use to be able to package up our application and send it up to Kubernetes. Let's do a similar thing with our Vue app. So we can build a new file, our .docker ignore, and here we'll want to ignore node modules, package lock.json. We can debate whether that was a good idea or not. Maybe star.orig, star.tmp. And then in our Docker file, let's go build that. We want to start from node alpine. Then we'll copy in all of our content into the workdir/src. We'll do npm install, then we'll run npm build. We should also run npm test if we had any. In this case, I don't. And so now we end up with our content in the dist directory. So let's say from node alpine, and we'll copy our content from equals build, the src dist directory into the current directory that is workdir/app. And then, well, it's just static assets now. Why don't we, instead of running it inside of Node, run it inside of Nginx? Nginx is great at hosting static resources. So let's do that. I'll flip over to the final solution here in Dockerfiles for each, and we can see this Dockerfile where we just copy our content into the user share Nginx HTML directory. That is that static place where Nginx hosts content. We also have an Nginx conf that will do a really interesting thing. It will go try to find the file at that particular file, and if it doesn't find it, it will host the index.html file, which will ensure that all of the 404 pages will launch our SPA app as well, so that the client-side SPA app can take advantage of all of the pieces. So we've got this Docker file then for our Vue app. We have this Docker file for our Spring Boot app. And now we can build this content. So if we go into 0 CLIs, into Spring Boot, then we can say Docker build. We can tag it with something like Java API step 0, and we can build it from the current directory. Now, I've already done this previously on both of them. Docker image list. We can see that we've got that Docker build right here. Here's Java API step 0, and that came exactly out of that build that we just did. We also have the Vue app step 0, and well, now how do we launch them? And that's what brings us to the end of our Docker 101 talk, where they go, ta-da, you've got containerized applications. But they're not talking to each other. They're just isolated pieces of equipment. So let's get deeper into this. How do we run our SPA and our API? How do we get the two of them to talk to each other? Should they be one container or two? Should they be on one domain or two domains? For example, should we have example.com and api.example.com? These are the types of architectural decisions that we now want to make with our containers once we've packaged up our things into images. So let's take a look at it. And I would argue it's not just a one or the other. I can run one container on a single domain, but I could also run two containers on a single domain. I can't run one container on two domains, so we'll X that one out. But what are our opportunities in each of these squares? What are the technologies that allow us to host our SPA and our API containers? Should they be the same container? Should they be different containers? How do they talk to each other? Now you're probably asking yourself, well, which one should I choose? Which one is the right answer? And I would argue that's probably not the right question. Instead, the question is, when should I choose each one? Now, each one has a best use case. So as we look through these three, let's see which one is your use case. Is your use case better for this one or that one? Does your organization prefer these types of mechanisms over the others? Let's take a look at each and see how we might choose to host them. So let's take a look at how we might deploy these images into production. One container or two? First, let's start with one container on a single domain. Now, in production, the way we're going to host this is the browser is going to connect to the internet and connect to that one container hosting both pieces. Now, that's cool. As we build the SPA's static files, we're going to host them inside the API server. So the way we'll do that is we'll build our SPA. We'll take our SPA's static files and we'll stick them into the API's static file hosting folder. So in development, we'll still use the DevPack web server. The SPA has the reverse proxy that hands /API things into /API, but in production, we're going to do this, put them both in one container. So let's see how that works. We built these two Docker files. We see the one for our Maven, our Spring Boot application, and one for our Vue app. Let's close both of those and take a look at the folder one container, one domain. Now you'll notice that we no longer have a Docker file inside of each folder. We're going to build one container, so we need one big Docker file out here. Let's take a look at that Docker file. Now we're going to start out building our Vue assets, our SPA content. Now we'll end up in the with the content in /src/dist. And now let's take a look at our Java app. Now we're doing exactly as we had before. We're downloading our Maven dependencies so that we can cache them. And then we're copying all of our content from the Spring Boot folder into the current folder. But then we're also copying our static files into source main resources static. Now this is excellent. If we put content here inside source main resources static, then it will get automatically hosted for us in our Spring Boot application. There's no code to change, which is amazing. So let's just copy that built content into there. Then when we package it, it gets bundled into our jar. And now our jar contains not only our built Java code, but also our SPA assets, /nicely hosted in the static folder. And the beauty of Spring Boot is that it will also automatically redirect index.html to /. So I don't have to worry about creating a / something like I might need to do in other languages. I just hit that URL and everything goes. So we could now build this. Let's come here into one, and I would say Docker build -t SPA and API one container, one domain. I've already done that. So if we say Docker image list, we see here's our SPA and API, one container, one domain. So let's run that. Here's the run instructions right here in the README. So we've done our build. Let's launch it. Now I'm actually not going to run it detached or in daemon mode. I'll just run it directly. That way we can see the console output. So now we're running our image. Now this image run as a container includes both our backend and our front end. So as we start this up, now we can just go to port 8080 once it launches. And let's be able to see our application. So localhost 8080, let's pull up the Chrome developer tools and we'll refresh it. We can see that the first request went to localhost 8080. And then when we looked for that weather forecast, it went to localhost 8080/API/weather forecast. Now that's perfect. Our application didn't need to know anything about the hosting platform. Everything happened on a single domain. And so we didn't have any cross-domain things. And we were able to get that response, the JSON, and we render it here in our page. That's perfect. So let's take down this container, Docker container list, Docker container RM. Let's remove this one. That stops our server. And so now if we were to push refresh here, we would get the nice 404 page. This site doesn't exist anymore. Isn't that great how easy it is to spin up hardware? That was excellent. One container, one domain. In this case, we packaged both pieces into a single image so that we could deploy it really easily. Now, this is great if we have, say, a Heroku instance or Azure Web Apps instance or Amazon Elastic Beanstalk site that we just need to deploy one thing. If we have a monolith, it's perfect. We don't need to be able to manage the difference between these two things. They're all packaged in a single spot. Now, on the downside, because we chose to package them in one container, we can't scale our front end and our back end independently. Now, that's okay. We've chosen not to in this case, but that's the biggest downside to this approach. When would I use it? If I have a Heroku account, if I have a single DigitalOcean account, I just want to host this one app, then I might choose to bundle these two things into one piece so that I could deploy it into one account. So I don't have to create two accounts, one for my front end and one for my back end. Next up, let's take a look at two containers, two domains. Now, in this case, I have my SPA on, for example, www.example.com, and my API is on api.example.com. Now, that means that the browser is going to load my home page from this container and then reach out to a completely different domain to load my API on this container. How do we implement this? Well, we have a bunch of CORS things, a bunch of access control allow origin, cross-origin request sharing as CORS. So what's interesting is the API has a whitelist of allowed domains, and the SPA has a hard-coded API domain. So when the SPA makes the AJAX request, the browser notices that it is cross-domain and automatically creates an options request off to that API to say, hey, am I in your allowed list? The API answers with that CORS header saying, here's the list of allowed domains, and the SPA validates that CORS header includes the current domain. This happens automatically and is not controllable by JavaScript. If that is successful, then the SPA reinitiates that original request, the get, post, put, or delete request, to that cross domain. Now, this is a browser-side validation, which means if I have a different Java app communicating with my API, then this cross-origin request sharing doesn't happen at all. This is not a security mechanism. This is an in-browser validation mechanism. So let's take a look at how this works. Now, we're starting with the 0 folder and taking a look at what we might do differently. Two containers, two domains. We have the Docker files in each one, and they build the standard thing. So we're not doing anything different here, with one exception. We've highlighted the CORS domain. Now, we've set it here as an environment variable so that we can change it as we start this application in each environment. Let's change it for production. Let's change it for pre-production. In our application, we have one adjustment here in our controller where we must, not the controller, the application, where we must identify the CORS domain. So let's go get that environment variable and let's initialize this, setting that as the allowed origins for any request within our system. Now, we could definitely tie this down to particular URLs, and we could have multiple domains here. But in our case, we'll just grab this from an environment variable that we set here in our Docker file. In our client app, we also need these .env files that include the URL of our server. Now, in this case, because it's running in Docker, we'll say, what's the URL from the browser? Well, it's localhost. So here in my components, in my weather forecast component, rather than just saying /API/weather forecast as we have in the past, we have to prefix it with that other URL. Now, this environment variable gets baked into the application as it's built because this environment variable needs to be set in the browser. So we can't control this later in our application. We can't start it up with a different environment variable set because it's baked into the application at build time. That means that we're going to need to rebuild this image for each environment. That's too bad. That means that we can't just promote a single image through each environment. Okay, so let's take a look at our application. We need to build our containers. I've done that previously. And so now let's launch our containers. We'll launch both the backend API and the front-end SPA as our separate containers. Now that we've got our two containers running, let's say Docker logs. I'm going to follow the logs for AEF13, our backend API, so that we can see when Spring is ready. It looks like it's ready. So now we've chosen to watch our front end on port 3000 and our back end on port 8080. So let's launch our front end, localhost 3000. Now we can see that it loads the front end API. That's excellent. Let's refresh this. It loads our front end and we got a 304, everything loaded correctly. When it goes to load the back end, we can see it gets a response and it's going off to that other domain. Now, in this case, they're both local hosts, but they're different ports. So the browser considers it to be a cross-origin request. So we can see in the response headers, we still have that cross-origin request. Taking a look at this a little further, where's the prefetch one? Oh, it automatically just baked it in. It does that prefetch to go validate the course header, and it's able to load this data correctly. Excellent. So in our two containers, two domains approach, we deployed two different containers in two different places. Now that's great. We can scale them separately now. If our backend needs more horsepower and our front end doesn't, then we can definitely evolve it that way. Or if our front end needs more horsepower and our back end doesn't, we can evolve it that way too. On the downside, we needed to do all of that CORS content, all the cross-origin request sharing. And because we need to bake that into our front end image is no longer promotable between the different environments. We need to rebuild our image for each environment. Now in our backend environment, we can inject that course header as part of starting up our application, but we can't do that with our front end. So we no longer get that automatically promote between environments. We must rebuild between environments. And that course header process is so easy to get wrong. The majority of places where you Google it, it'll say how to turn it off. So where we've specifically set it to a particular domain, a lot of people just disable security and set it to all domains, which leads us open to clickjacking concerns. So let's stop these two images. Docker container rm-f, that one. Docker container rm-f, that one. Docker container list, and we're clean. Excellent. So next, let's take a look at, so when would I choose this? When I have two different teams working on the front end and the back end, and they need to be very isolated. When I have a solid naming convention or other interface conventions between these two teams. Now this is cool. Next up, let's take a look at two containers, one domain. Now this is really brilliant. We have a reverse proxy here in front of the two containers, and this one listens to say, is it example.com or example.com/API? If it's just example.com, it'll go here. If it includes /API, it'll go here. The browser believes it's connecting to a single site. So we don't have any course headers, but we're still able to scale those two containers separately because, well, they're running separately. The magic happens here in this reverse proxy. So how do we implement it? We use a Kubernetes ingress. Now, Kubernetes ingress allows us to be able to match paths and redirect to different containers. So let's take a look at how this works in development. In development, we're still using Webpack Dev Server. Webpack Dev Server is that reverse proxy, and it's built into our SPA, and it'll just take /API requests and forward it to the backend. But in production, we have this Kubernetes ingress that redirects us to these two places. So let's take a look. Here inside two containers, one domain. Ooh, there's a few typos. I would love to learn about the typos offline. Thank you, Serafima. Here we just have the regular Docker files. These aren't different in any way. Both the client side and the server side, they're just the standard images. We have the multi-stage build to get advantage of caching and avoid leaking secrets. And the magic happens here in Kubernetes. Now we have a deployment for our backend that will start our backend image that we've already built, java-api/2 containers, one domain, and it'll start on port 80. It's a little mad because I don't have a resources not restart, resources. I haven't specified resource limits, and so that's why it's a little mad there. Now, in this case, it's specifying that I should only have one backend replica, but it does highlight those things. A service in Kubernetes is a load balancer across all of the instances of this application. So it says, if anyone connects to me on port 8080, forward that off to port 8080 for this particular deployment. So let's do that. We also have those for our view app, a deployment listening on our view app. In this case, we have 2 replicas for our front end, and we have a service for our front end called view app doing similar things. And here's the magic, is the Kubernetes ingress. Now, what the Kubernetes ingress says is that if the path includes /API, go to the backend API. And if it doesn't, go to the front end SPA. So let's launch this. We'll go to 2 containers, 1 domain. And we will kubectl apply -f k8s. Now, what I like about apply is it is both create or update. And if I pass it a folder, it will enumerate through that entire folder, applying each of those pieces. So kubectl get all and ingress. We can see that all of those things are running. We've got 2 copies of our front end, 1 copy of our back end. Each of those services, load balancing across them. We can get the node ports if we need to, but we also have ingress running here. And so that's running on port 80. So let's come here to localhost port 80, not 8080, port 80. And we can see that our ingress correctly routes content between the 2 things. According to our browser, it's just one site. Localhost comes to localhost to load our front-end SPA. When it calls the API, it's also not cross-domain. So our front end believes that all of this content is running on a single domain. But under the hood, we know that we have this reverse proxy here so that it can pass some things to this container and some things to this container. That's excellent. Now we can scale our content independently. We don't have to worry about CORS headers. We don't have to worry about hard-coded URLs or rebuilding our content for each environment, but we still get that separation between our systems. Now, this is excellent. On the upside, we're able to scale our things independently, but still host them on a single domain. On the downside, we do need Kubernetes to pull this off. So if we only have a single Netlify account or a single Azure Web App or DigitalOcean account, then this isn't the solution for us. Also, the entire backend needs to be hosted or proxied under that subdomain. So we may need an API gateway or another mechanism to be able to get all these things hosted under a single thing. Now, the cool part is they don't have to be a single container. They just need to be exposed as a single domain to our SPA so that we don't get cross-origin requests. So I will choose this one when I have Kubernetes available, when I need to be able to scale my front end and back end differently, because it's a great way to be able to avoid the CORS headers, but still be able to scale separately. Another bonus technique, a server-rendered SPA, we might choose to have our back end pre-render our front end. Now, that's an interesting technique, but for the most part, it requires that we have a server that is running Node because, well, client-side JavaScript. So here's some examples of server-rendered SPAs. It works best if I have a JavaScript runtime server-side, and it's great for when I need SEO of my target website. If I've logged in first, a server-rendered SPA may not have the same benefits. I'll choose this when I need that SEO for my public-facing website. So here's the 3 choices that we had. 1 container or 2 containers, single domain or subdomains. If I have 1 container with a single domain, I'll put my SPA content in my API's public folder so I can host them both from a single container. I'll do this in the case of a Heroku or a DigitalOcean account, where I only want 1 account for a single monolith. 2 containers on 2 different subdomains. I need to bake those base URL and CORS environment variables into the containers. And in the case of the client container, I do have to bake it into the image, which means I need to rebuild it for each environment. With 2 containers on a single domain, I use a Kubernetes ingress to be able to reverse proxy traffic to the particular container that needs it. So which solution is the best? It totally depends on your needs. Are you hosting a monolith? In which case, maybe the one container, one domain is the proper solution. Do you have Kubernetes available and you're hosting many microservices? Maybe the multiple containers on one domain is the correct solution. Do you need a very specific separation between these? Then maybe 2 containers on 2 domains is the right solution. Ultimately, this is the solution that best matches your needs, and all of the source code for all of these different solutions is available here up on GitHub. If you're inside the Java folder, you can get at each of the solutions that we saw today, or if you'd like to see implementations in other languages, then you can take a look at those as well. All this content is at robrich.org. It is available online right now. If you're watching this session on demand, I'd love to hear your questions at rob_rich on Twitter. For those of us here live at the event, what are your thoughts? What are your questions? What should I include next time when I do this talk? Ooh, how does server-rendered SPA help with SEO? Great question, Rizwan. Because I've pre-rendered my application, then Google can see the HTML in my app. It doesn't need to run the JavaScript to be able to see it. So that makes that content available for SEO, and because Google can see it. A lot of times when I just have a SPA, then Google's like, well, I don't want to render your JavaScript. So that's where a server rendered SPA can make that HTML available for Google search engines, in addition to maybe making it a smidge faster for users. Great question. What about SPA consuming multiple APIs on different containers? Great question, Ketlin. Now, in the case of a Kubernetes ingress controller, we could specify them here in our content. So we could say /API/server1, and then we could have another one here for server2 to Java API 2. And we could then specify multiple backend APIs there. In the case of 2 containers, 2 domains, now we need to have multiple base URLs. So we'll have what is the URL for server 1, server 2, server 3, but the APIs only need to know about that single client. So we'll have just multiple URLs here. Great question, Catlin. Was in the live coding part. Didn't know you had prepared copies. Oh, the typos when I live coded these Docker files. Good question. Good comment. I didn't actually run these because, yeah, I probably had typos all over. Oh, there it is. Dependency. There we go. Yep, I had copy. I had typos, which is why I didn't run these. Good catch. Do I have an example of server rendered code in my source code? Server rendered code works best if your backend is JavaScript. And so I don't have an example in Java. I do have an example in .NET because .NET does some, no, actually, I don't have one in .NET. And I also don't have one in Node. No, I don't have an example of a server rendered SPA. Time for me to do that. Great suggestion. Oh, yes, I spelled dependency. I spelled it with an A instead of an E. Good catch. Thanks, Vinkata. Also, my Maven folder. I typoed my Maven folder. Yes, that would have not worked at all. Good catch. Well, this was a lot of fun to be able to show you how you can host a Java application and the front-end single-page application to consume it in containers. I'm glad we were able to get past just the standard Docker 101 talk to really show how these things can integrate well together. Grab these slides and the code at robrich.org. They are online right now. And if you find a question tomorrow or next week, hit me up on Twitter at rob_rich. Thanks for coming.